In Lesson 4, we're going to have a look at ESXi itself. ESXi comes in two different flavors. There's a free version that we call the vSphere Hypervisor that is limited in certain ways. It can't be managed by vCenter Server and supports only up to about 64 gigs of RAM. I believe that's the number today. But then there's the version that we all get, which is the fully licensed version, that has a number of really great features. First of all, I want to talk about some of the security features around ESXi. To date, there has been no known malware developed for ESXi, and there's a number of reasons for this. The first thing is that we have a host-based firewall that is enabled by default, and that prevents external access to ESXi except through vCenter Server. And in order to get that access through vCenter Server, of course, we need credentials for the root account to allow us to do that. Okay? All other systems, things like SSH is disabled by default, the ESX shell itself is disabled by default. Any other interactivity with ESXi is disabled by default. We also harden the memory for ESXi, and that is anytime a virtual machine wants to place some data in a page of memory, that location is randomized. So you can't actually expect to find anything in any regular location in your physical memory footprint. It makes debugging and actually crawling the RAM nearly impossible. We also maintain the integrity of all of our kernel modules by digitally signing those kernel modules. We bundle the kernel modules in something that we call VIBs, or VMware or vSphere infrastructure bundles. And those bundles contain the components of ESXi, and before they're extracted and loaded into memory, we check that digital signature to make sure that it's good. And if it's been modified in any way, shape, or form, we'll purple screen ESXi, similar to like a Microsoft blue screen of death. But we do this on purpose in order to prevent the compromise of any memory, any of the contents of the memory of an ESXi host itself. Now, we also support the Physical Trusted Platform Module 2.0, along with UEFI Secure Boot. And what these two systems go to do is to chain a certificate, a set of certificates that ensure that not only does the physical firmware attest that ESXi has not been compromised, but then each of the modules that continue to load in the bootloader for ESXi have also not been compromised and are intact as they came from vSphere. As the bootloader then begins to load the kernel, our kernel module integrity checks kick in to ensure that each of the components along the boot string make sure that they are intact and that those have not been compromised. So you can be sure that when you boot ESXi, that it is secure, that it hasn't been compromised, and that it's intact, and that no malware has actually infected it. Now, in some cases, we can extend that security into the virtual machines themselves. And we'll talk about all of the different features of virtual machines, but one of them is virtual machine encryption. So we can encrypt the virtual disks of virtual machines. And when we go into what we call this crypto safe mode, it also ensures that if there's a core dump, if there's a crash of the ESXi kernel, and the core itself is dumped into a file, that core dump itself is encrypted to ensure that nobody can get access to the RAM. So a lot of really great features around the security of ESXi itself. One of the other nice things that is that it's a very small disk footprint. We can distribute this thing in about 350 megs, and that includes the VMware Tools ISO images that are included there. So it's a really very small footprint. We support quick boot on certain hosts so that we can actually do warm boot of ESXi to lessen the downtime incurred for patching ESXi itself. And we can install ESXi to just about anything that we can boot your host to. This includes local hard disk, remote LUNs for Fiber Channel and iSCSI. We can install to SSD and USB devices and SD cards and little SATA DOM devices that are kind of like memory devices that plug straight into the SATA ports. We can do diskless hosts, and we can PXE boot ESXi if you want to as well. So one of the things that we have to do is we have to boot the ISO image that comes downloadable from VMware, and we'll install ESXi. And once ESXi is installed, we can configure this through the direct console user interface, which is a text-based UI, keyboard interaction only, and very, very simple. You really don't want to use this DCUI except to do the very initial configuration of perhaps the management network itself, right? This is the IP address by which ESXi is known to us and to other hosts. Okay. But once we dive in, you'll see there's a number of things that become readily apparent. Things like its fully qualified domain name, our ability to manage the host, and we can also dive in and we can hit F2 to customize the system and to view the logs. So let's go ahead and do that and hit F2. Once we hit F2, it actually asks us to log in. We're going to log in with the account root. We will have set a password during the installation. It doesn't require a password, but if we choose to put a password in here, it actually does require a complex password. At some point, even during the installation, if we haven't chosen a password, we'll need to select a password for root. Here we can change the password or want. We can enable or disable lockdown mode. Lockdown mode is a very nice feature that has to do with the security of ESXi, but also the management of ESXi. When vCenter comes in to manage ESXi, we want to make sure that users aren't directly attaching to ESXi to do the management, because vCenter keeps a periodic check on ESXi to make sure it knows what virtual machines are running there and how performance is doing and that sort of thing. Does it every 5 minutes. We'll go out and we'll check ESXi from vCenter. But if we've made modifications to ESXi in the meantime directly at ESXi, and we haven't done it through vCenter, then we can have a few things where there's a missynchronization there, and we don't really want that. Okay? Enabling lockdown mode prevents users from directly managing ESXi except through vCenter itself. Now, the management network is something that's really important. The management network will be the primary IP address of your ESXi host. Okay? So we can configure the management network, and we'll show you that in a moment. We can restart and test the management network. And if we've made a misconfiguration and lost communication between vCenter and ESXi, we can restore the settings for the network as well. Okay? We can set things like the host name, its IP address, its fully qualified domain name. We can configure vCenter's DNS servers and the like. Later on down, we see troubleshooting options, and we see how we can do things like configure the keyboard. Configuring the keyboard says what language, right, are we going to configure ESXi into. Okay. Troubleshooting options allow us to enable and disable the shell for ESXi, as well as SSH, and set things like the timeout value for how long do we want to leave the shell and SSH available. Of course, ESX shell and SSH are disabled by default because they are vectors for attack. That's not saying they aren't secure, but certainly any ports that are left open can be attacked. Whether the attack will be successful is another story. So it's a best practice to leave those systems disabled. So if you turn them on, you can set timeouts so that if you forget to disable them, they'll disable those services itself. Now, you can also make those configuration changes from the vSphere client or the vSphere host client. So here's our first real picture of the vSphere client. Here we've got our vCenter server, and we'll talk about creating logical data center, but here we have the management of a couple of ESXi hosts. We can click on one of those and go to the configuration interface where we can set the configuration for the firewall of ESXi. The firewall is enabled by default, and it blocks all incoming and outgoing traffic except those that are explicitly allowed by the firewall itself. Here we can manage the different services, things like the NTP services, Active Directory, and so on. Here we can look at the security profile, which allows us to change lockdown mode, for example. Do we want to prevent systems from directly attaching to and managing ESXi? Wouldn't we rather restrict that management to vCenter? And as a best practice, the answer is yes, of course. Speaking of best practices, let's have a look at how we manage our user accounts. Now, anytime we install an ESXi host, there is an account there called root. And it's by default that this root account has full administrative privileges over the host. And we'll set a password there. Now, it's not a good idea to use that account at all. In fact, anytime we have an account that has full administrative privileges, it becomes an issue of, can I make mistakes in the management of this host? And of course, the answer is yes, I'm human, I'm going to make mistakes. So why don't I give myself another account through which I can manage ESXi that doesn't necessarily have full administrative privileges? Best practices related to privileges in any environment say, give our users access to do the things that they need for their jobs, nothing more and nothing less. And if you don't need full administrative access, then let's not use that root account. Let's use some other account. Okay? Now, we can create other local accounts, but we can also integrate ESXi with things like Active Directory. So you can add ESXi to Active Directory and then use Active Directory accounts and assign those AD accounts privileges within ESXi to do a number of different things. And in fact, ESXi has a wonderful role-based administration system that allows us to set groups of users the ability to do certain things and not other certain things. So Active Directory is a really great way to manage those accounts. And in fact, what we want to do is rely less on local accounts that we will have created and more on central authority accounts like Active Directory. Because after all, if you have a significant number of ESXi hosts in your environment, that means for every single ESXi host, you'll have to create a series of local accounts for your users. And then if your users or your administrators actually happen to leave your organization, you have to go through all of those systems and remove those accounts and so on. Okay? So best practice, log in with Active Directory accounts and require strong passwords. One of the most important things that we can do during the initial configuration of ESXi is to ensure that all of our systems have synchronized clocks. And in doing this, we're going to use the built-in NTP client. We'll point ESXi to an NTP server. We'll tell our virtual machines to use those same NTP servers as their source of time as well. There's lots of different ways we can do this through Active Directory. Members of domains get their time from the domain controllers. The domain controllers can get their time from their NTP servers like ESXi itself. Now, this is important for a number of reasons. Of course, if we're using Kerberos-based authentication like Active Directory does, much of those certificates that are involved there rely on time. So if you have a significant time drift between systems, especially the Active Directory client, and in this case, ESXi or vCenter would be that Active Directory client, and your Active Directory domain controller, if there's time drift there, authentication will not work. Okay? You also need synchronized time for managing logs and troubleshooting and performance graphs and all of these things. So it's important to configure ESXi as an NTP client and make that configuration uniform across all of the systems in your environment itself. What we're going to do now is we're going to dive in to an installation video where I'll walk you through the process of installing ESXi on one of your hosts.